Normal distribution. Normal distribution is a function that represents the distribution of many different variables as a symmetrical, bell-shaped graph. In real life, it is used for statistics and is used for probability of success, probability of failure. The graph of the standard distribution depends on two factors: the mean and the standard deviation. Mean. The mean of the distribution determines the location of the center of the graph. Standard deviation. The standard deviation determines the height and width of the graph. When the standard deviation is large, the curve is short and wide. When the standard deviation is small, the curve is tall and narrow. Z-score. The normal random variable of a standard normal distribution is called a standard score, or Z-score. Z equals x minus u divided by the standard deviation. Example 1. An average light bulb manufactured by the Acme Corporation lasts 300 days with a standard deviation of 50 days. Assuming that the bulb life is normally distributed, what is the probability that an Acme light bulb will last at most 365 days? Normal random variable 365, mean 300, standard deviation 50. We enter the numbers into the Z-score formula and the answer is 1.3. Equivalent probability is a 90% for Z equals 1.3. The right answer is that there is a probability of 90% that the bulb will last at least 365 days. Example 2. Bill claims that he can do more push-ups than 90% of the boys in his school. Last year, the average boy did 50 push-ups with a standard deviation of 10 push-ups. Assume push-up performance is evenly distributed. How many push-ups would Bill have to do to beat 90% of the other boys? Cumulative probability 0.90, mean 50, standard deviation 10. Equivalent Z-score to 90% probability equals 1.28. Using Z-score formula to solve the X variable of push-ups. The final solution is Bill needs 63 push-ups to beat 90% of the boys in his class. Example 3. The amount of mustard dispensed from a machine at the Hot Dog Emporium is normally distributed with a mean of 0.9 ounces and a standard deviation of 0.1 ounces. If the machine is used 500 times, approximately how many times will it be expected to dispense 1 or more ounces of mustard? Normal random variable equals 1, mean equals 0.9, standard deviation equals 0.1. Using Z-score formula to calculate the Z, equivalent probability to Z value of 1 equals 15.86%. Least number of sausage exceeding 1 ounce equals 500 times 15.85% equals 79.3. So our final answer to the nearest sausage is 80.